cosine rules used for triangles that are non-right angle. So if it's a right angle triangle, you don't use these rules. But if it's a non-right angle triangle, we use this convention for labelling the sides. It doesn't really matter what letter you use. In this case, A, B, C, capital A, capital B, capital C, for the angles. This symbol hat above the angle means it's angle A, angle B, and angle C, so I could have put those little angle symbols there. The key thing is, though, that the side opposite angle B is side B, and so on. So the side opposite angle A is side A, and C opposite C. If that little convention is used, then the sine rule says that the ratio, this is a ratio of this fraction, the ratio of sine A to side A to sine of the angle A is the same as the ratio of the side B to that angle, the sine of that angle, the side C to the sine of that angle. Yeah. No, what you need to do is just assign yourself the letters to the sides. It's up to you. Now, there's three ratios there, so don't let that confuse you. Generally, no, I've just written an example there, but no, that's correct. You need some information to be able to use the sine rule. You need at least one angle to be able to use the sine rule. We don't generally use all three ratios. The sine rule just states that these ratios are all the same. Basically, that's what the sine rule is saying. But in practice, we only ever use two. So I might use that the ratio of A to sine A is the same as B to sine B, or any of the others. So we actually only ever use two of the ratios. So don't let that confuse you. Let me show you by example how this works. So all this sine rule says is that the ratio of this side to the sine of the angle opposite it is the same as the ratio of that side to the sine of the angle opposite that. So really we don't even need to write down the sine rule. The sine rule will work so long as we know one ratio. Cameron. The sine rule will work so long as you know at least one ratio. Look at this example. I know one of the ratios. That means I know one side and an angle opposite it. And that's key. If I don't know a side and an angle opposite it, I can't use the sine rule. So when do you use the sine rule? When I know an angle and a side opposite it, then I can use the sine rule. So I look at this and say, I can use the sine rule to solve this. I'll write down the ratio I know, 3 over sine 30, that's the ratio I know. And then I'll write down the other ratio, which involves what I know, the other angle, which is 80 degrees, and what I want to find, x over the sine of 80. It also equals that side over that side, but I'm not interested in those, so I only write down the two ratios. Okay? Now it's a little equation to solve. What I did is I've got to get x, so multiply both sides by sine 80, 3 over sine 30, multiplied by the sine of 80 equals x. And now get the calculator out and work it out. So x equals 5.9, x is 5.9 to two significant figures, which is an appropriate accuracy. Okay? Of course, in examples like this, we could actually find all the missing sides. If we look at this, particular example, by definition, if I know two of the angles, I know all three, because in a triangle, all angles add up to 180. So I actually know what this missing angle here is, so I could find this missing side, but I wasn't asked, but I could do easily. Yeah. No, can't use that because I haven't got right. Okay, Okay, so we can't use Pythagoras any more than we can use sine, cosine, tangent ratios. Okay, so we could find this missing side here. So as a little extra, find out what this side is. Call it y. So find y for me, please. So finding y, you should end up with this value, 5.6 for y. The problem in this example might well be find the missing side and the missing angles, theta and using Greek symbols. Okay, find the missing side and the two missing angles. Can we use the sine rule in this example is the first question, because there's no right angle, but what's the key thing for if we can use the sine rule? Exactly, we know one ratio counter, we know one side, 8.6, and we know an angle opposite it, so we know a ratio, so we could use the sine rule. So we want to find x and these missing angles. Well, what's the only thing that we can find at the moment? Theta, yeah, because yeah, but we've got the 9.8, exactly right. If you look at this, but this is part of it, we can use the sine rule because we know one side and the angle opposite it, and then we look at the other bit of the relation, we know it's this, so that allows us to find the angle opposite that, and then once we know that angle, we can then find the other angle, because we will add up 180, and then once we know that, we can find x. So that's the sort of plan, okay? So the first step, so to find these things, number one, find theta using the sine rule, like our plan. Two, find alpha, because all angles add up to 180 degrees in a triangle. And then three, once we've got alpha, we can use x using the sine rule. So again, it's a good idea to think about the problem and what you're going to do, and then in some cases even maybe write down. Step one, find theta using the sine rule. So we write down the ratio we know, 8.6 over sine 40 equals the ratio we're interested in that involves what we know, 9.8. So it's 9.8 over sine theta. So we should be able to find theta because that's the only unknown. The first thing to recognise about this is that the ratios, let's go back to the start, let's look at the sine rule. These ratios could easily have been written the other way around. If the ratio A to sine A is the same as B to sine B, I could easily just flip those and say the ratio of sine A to A is the same as the ratio of sine B to B. So the ratios could be written either way up. In this case, it's useful to have it the other way up, because what I'm trying to find is underneath it. So instead of writing it this way, let's split these ratios. So at the start, you could have written that and say, therefore, sine 40 over 8.6 equals sine theta over 9.8. So you could write the ratios either way. Yeah, no, that's right. That's why I'm going through this one, because it's a new step, so I'm going to take you through that now. So we've got to get sine theta on its own. So let's have a look. Again, multiply both sides by 9.8. So sine theta equals sine 40 over 8.6 times by 9.8. But as Cameron says, we want the angle. So sine of theta is that, so it's sine to the minus 1. So therefore, theta equals, and this is the key step, sine to the minus 1. The angle whose sine is, brackets, sine 40 times 9.8 over 8.6. And you can actually type that into the calculator like that. So sine to the minus 1, open brackets, use the fraction button to put this in. And then get the answer in one hit on the calculator. So if you could do that, so we get theta equal to 47 degrees. Now we've got theta, we can then go to steps 2 and 3 and find alpha and x. So if you could just finish that problem off, please.